We are excited to kind of present this today. We recently actually presented this at Oracle Cloud World. This is pertaining to identifying rogue SQL, essentially covering one of the main feature of our service, which is OCI Ops Insights service within OCI. We'll be talking about some of the techniques and the methodologies that we have used within this application, and we'll be discussing more in detail about that. All right. With that, a quick overview about myself. So my name is Murtaza Hussain. I'm part of Director Product Management within Observability Management team. And I'm here accompanied today with John. He's an architect within OCI Ops Insight Service. All right. In terms of the agenda, we'll be covering high level about the service overview. Basically, Ops Insight Service will be covering some of the nuts and bolts and solutions that entail the service. And with that, we will switch over to talking about some of the challenges that are faced by modern day database administrators and database performance folks in terms of SQL manageability. And then JB will be kind of covering about some of the technical overview of the SQL Insights service and how this SQL Insights application helps overcome some of these challenges pertaining to SQL manageability. All right. Towards the end, we have like 5 minutes left for Q&A. We'll kind of cover that. With this, let's get started. So this is kind of like the overall Oracle multi-cloud observability management portfolio. So essentially, it provides solutions that improve user experience by offering a curated set of services and applied observability that helps customer discover, operate, secure, and improve build complex distributed IT systems, especially when end users are not technical experts in the underlying systems themselves. So what you're seeing over here is what we do is we essentially allow to ingest data from different sources, right? Whether it's various CSPs, cloud service providers, OCI, Microsoft Azure, Google Cloud, and AWS, or even with on-premise, we have support for that. We ingest that data, and the types of data and telemetry data that we ingest is metrics, events, logs, traces, and SQL. We call this MELT. And what we have done is we have built these purpose-built use case specific services on top of this data that we ingest. And that is part of observability management platform. So starting from the left, we have application performance monitoring, which is looking at the performance monitoring around applications holistically from that angle. Then we have stack monitoring, as the name says, it's more focused on the monitoring use cases across the stack, whether you're talking about applications such as EBS and all that, and all the underlying data, all the way to the databases and host that is supporting those applications. Then we have logging analytics that has ML infused insights around the logs that are being listed into the service and providing insights around that. Database and OS management is more focused on the monitoring and the performance-oriented use cases for databases. And lastly, we have Ops Insights. That is the focus of the discussion today, which is looking at the long-term telemetry data across these different sources and providing you insights around that. Some of the key use cases that are entailed in the service is looking at the capacity planning across databases, hosts, and Exadata systems. And some of them are more geared towards looking at the database performance across your deployed databases on the service. With this, I'll move on to the next slide. Yeah, so before we double click on the service, I wanted to kind of give you a quick overview of what OCI Ops Insights service is, right? So if you start from the left-hand side, essentially what we look at is we give the flexibility to the users to ingest data from different deployment type, right? So we support OCI cloud-based resources. We support on-prem, multi-cloud, which is Oracle DBAs, Azure, and others, AWS, and now with GCP is also on board with the multi-cloud. And we also support on-prem entities which are supported and enabled through Enterprise Manager. So that is also supported. So once the data comes in, we have a highly secure, scalable, autonomous database that stores all this data, telemetry data coming from different deployment types. And we store it for a very long period. We store it for 25 months historically, and it's in a centralized tenant-specific data store, right? And what we have done is we have built these ML-infused applications and data exploration applications on top of this data, right? It provides you insights around some of the specific use cases around capacity planning. SQL Insights, that is something which we'll be covering today more in depth. We have data explorers that basically lets you author custom SQLs against data objects. That is something which is very unique to Ops Insights service. And lastly, we have Exadata Insights that is more geared towards capacity planning use cases for your fleet of Exadatas that are enabled on Ops Insights service. All right. So these are some of the key features, solution areas that entails Ops Insights service. Starting from the top, right, we have capacity planning, as I just mentioned. It's essentially looking at trending and forecast of your compute, database, and Exadata systems, right? It ingests this underlying metrics around CPU, memory, storage, and I/O, and then it lets you do forecasting on top of that metric data, right? We have ML if used, AutoML based forecasting models that you can utilize to trend and forecast your very important metrics that are based on this. Next, we have Exadata Insights that is, again, looking at capacity planning and chargeback use cases, more focused from Exadata and fleet of Exadata systems that are enabled on the service. SQL Insights is something that we'll be kind of focusing on today. That is looking at, from a fleet-wide point of view, SQL level performance insights across your fleet databases, and then providing you in-context drill down from a fleet level to a database level of your interest, and from a database level to a SQL ID level, and looking at the insights from that perspective. Next, what we have is Atom Spotlight, that is essentially providing a strategic view across Atom runs for your fleet of databases and providing you insights in terms of, I should say, actionable insights that you can utilize to basically make changes to the performance and fine-tune the performance of your databases, more from a DB time perspective. AWR Hub is it's part of our warehouse story within Ops Insights, where it lets you ingest AWR data, snapshots from the source databases, whether it's in the cloud or autonomous database, into a centralized cloud-based repository. And then we have built these applications, which are AWR Explorer, which lets you visualize and kind of analyze the reports, AWR reports, and the data, underlying data in an analytical way. Lastly, we have Data Explorers, which is, again, very unique to Ops Insights, which lets you explore the data against data objects, lets you curate a customized SQL. And then once the SQL has been customized, you can basically build widgets, and those widgets can be converted into dashboards using the dashboard framework for visualization. What you see on the right-hand side is just to kind of give you a quick overview. This is the landing page of the service. We have all the applications that we just kind of mentioned and went over are listed on the left-hand side. You can see the fleets of databases and hosts that are enabled on the service, right? And some of the important material are on the different applications that you can read from the landing page.
All right, so thanks, Murtaza. That was an excellent introduction to Ops Insights, and it's an exciting, relatively new service. We've been around for a while, but just starting to get traction. So I hope the attendees will be interested. So SQL Insights is really focusing on SQL, and just to sort of introduce the topic, we're going to talk first about just manageability, the challenges of managing SQL, basically, SQL workloads, frequency, footprint, seasonality. There's just lots of issues, and I'm sure any DBAs and app developers will be well aware of those. We'll give a brief technical overview. We're not going to go too deep, but we'll, kind of scratch the surface of the technology in a way that will hopefully give you a pretty good sense of what we're doing. And then we'll talk about a couple of the use cases that we attack with insights, plan changes, and cursor sharing. So managing SQL workloads isn't easy. I mean, SQL, it's one word for like an infinitude of possibilities, right? So, we think about SQL as a kind of I don't know what I want, like a one thing, right? But really, I mean, there's just so much variability in SQL. And on the left here, I'm just kind of emphasizing some of these things. You've got, well, first of all, workloads. What do I mean by workloads? I mean, basically, the collection of SQL that runs more or less at the same time. Now, we're not talking about exact concurrency, but the SQL that ran in between 12 and 1 p.m. on my big database, I would call that a workload, the collection of SQL that ran at that time on that database. And there's very different kinds of workloads. So OLTP workloads tend to be very high frequency, low latency SQLs. Individual executions are usually very inexpensive, but they happen many, many times per second, possibly. Analytic and batch SQL is kind of the opposite, right? Whereas each execution of an OLTP SQL has a light footprint, but it executes many times, this analytic or batch SQL is typically very low frequency, but very large footprint, right? So, you may have parallel queries that are taking up, large amounts of resources when they execute. They can execute for hours versus microseconds. And then there's ad hoc queries all the time. Maybe not in your production databases, but maybe, right? And these could be single execute SQLs or infrequently executed SQLs. They may be REST service calls, is kind of a relatively new sort of profile for SQL workloads. And then the reality is databases, there's very few pure OLTP databases or pure analytic databases, right? Most databases of any consequence are running some kind of mixture of these types of SQL. So, there's lots of different sort of profiles and footprints of the SQLs that are executing in your database. And so this introduces, significant challenges for DBAs, right? Just the volume and the variety of SQL. You've got, select is sort of the most common SQL statement that you would likely find, but inserts, updates, and deletes that actually affect data are very important to know about. PL SQL is often used to wrap multiple SQL statements. And there can be many thousands of SQLs per day. And so basically, it tends to be the case that we're very reactive, and you tend to find out, oh, this SQL went bad, and so everybody deep dive on SQL ID 1, 2, 3, 4, 5, 6. Or, so it tends to be a very reactive and one SQL at a time, looking at the problem SQL. And very little attention, I think, is paid to sort of the aggregate, what's happening all together, right? What is all the SQL doing? What are the properties of the workload, right? And so that's really one of the key things we wanted to address with SQL Insights. And then, of course, in a fleet context, every database could execute thousands and hundreds of thousands of SQLs. Well, you might have hundreds of databases, right? So now you're talking about millions, perhaps billions of SQLs, right? So, just the scale of things, if you're trying to talk about things at the SQL level, the SQL ID level, I mean, but from an enterprise perspective, that becomes a pretty significant matter of scale. So some of the goals for this feature, first and foremost, having a credible performance warehouse of SQLs that have executed in your database. We want to capture a history of the majority of the SQL workload. Now, we can't make a claim that we capture all the SQL, right? It's just not feasible. But we do make the claim that the collections we do should provide good insights into the core properties of your workload, in addition to all of the high load SQLs. All the most important SQLs should be in our collections, right? We basically feel that it should be very unlikely that you take an interest in a specific SQL and you don't find it in our warehouse, right? It's possible, right? But it's unlikely, in my opinion. And I'll rely on you to verify that. Built-in ML insights, we don't use super fancy ML. In fact, ML purists would probably say half the things we do shouldn't even be called ML. But what we do is, we look for, certain patterns in the performance statistics of your SQL that are consistent with important things you might want to know about. Now, so we'll talk a little bit more about that when we get into a couple of specific insights. Also, we wanted to offer, some kind of a UX, a data warehouse of SQLs with, let's say, a SQL Plus interface is really going to be kind of tough to use, right? And so, we have three dashboards, one at the fleet level, one at the database level, one at the SQL level that were built with our dashboard technology. So they're not quite as rich, let's say, interactively as maybe a very carefully crafted JET application or something like that. But they are, you'll see screenshots. They're very informative and have very nice visualizations of the workload that we've collected. And then we also enable and provide facilities for doing ad hoc workload analysis. So we have this technology we call data explorers. We have a dedicated SQL Explorer. And those things basically can be used to write queries against data objects. The data objects are basically how we externalize the data we've collected. So they add some things to the raw data, like configuration information about the database that it was collected from and other things like that. And then provide you a sort of a SQL-like, as basically a SQL interface into this, into the data that we've collected, the SQL data. And you can use these to create your own dashboards and widgets, first of all, and then dashboards, which are just assemblages of widgets. And so you can write a SQL, you can write a query against a SQL data object that will produce outputs that can then be visualized in a widget and then combined with other widgets into a custom dashboard. And that's very nice technology. So let's just get a little bit into the technical stuff. So we collect, curate, analyze, and present SQL performance history data. So in terms of the data source, it's SQL stats, $SQL stats. If you're a DBA or if you've been studying AWR reports for any time, you'll know that there's an internal observability telemetry construct inside the database called $SQL stats that basically keeps very high accuracy performance statistics at the SQL ID level. Okay, and so when I say high accuracy, like the times in here are measured in microseconds. The counts are exact counts; they're not estimates. And one of the key things here is that SQLs execute when they execute, right? And unlike other stats you might be familiar with inside the database, which all kind of zero out when the instance restarts and then accumulate from that point forward, SQL stats, the measures in SQL stats accumulate when the SQL is first loaded into the shared pool, right? And every SQL gets a different load time, right? The first load, they don't all load together when the instance restarts, right? When somebody asks, when some user submits a query that's never been seen before, or at least since the instance restarted, well, then that's when an entry in SQL stats gets made for that SQL, right? And that actually presents, one of the key challenges that we have. In terms of the data collection, I don't want to dwell too long on this. Basically, every 30 minutes, we wake up and scan SQL stats for any SQLs that were active in the last 30 minutes. And so, we're really trying to get a progressive view of the workload as the day goes on. We do some schema filtering. We use a GB dollar. These are not really important details about the GB dollar thing. But then for all the SQL that were active in the last 30 minutes, we have a kind of a combined ranking mechanism that takes into account CPU, IO, executions, total elapsed time, which is DB time, right? Elapsed time of SQL is part of DB time. And we use basically, how do we rank SQLs that have actually accumulated since various start times, right? So if one SQL started, 10 days ago, was loaded into the shared pool 10 days ago, and one SQL was loaded 10 minutes ago, well, it's kind of hard to rank on the absolute values of the measures, right? Because the one that was loaded 10 days ago might have been executing once per day, but it still has 10 executions, and the one that loaded 10 minutes ago just executed once, right? Well, maybe the one that loaded 10 minutes ago is going to run every 10 minutes, right? So it'll execute, whatever the multiplication amounts to per day, right? So we're kind of comparing apples and oranges at that point. But conveniently, since I don't know when, maybe Oracle 11 or 12, SQL Stats has actually been keeping track of how much the performance measures accumulated since the last AWR snapshot. And that's the key thing, right? Because the last AWR snapshot is a single point in time that is relevant to all the SQLs, right? And so we can compare them on the basis of how much they've done since the last AWR snapshot and make a meaningful kind of ranking mechanism there. So that's a little kind of a detail that's probably beyond, but is sort of key to kind of getting a consistent sampling mechanism. And then we select the top 2,000. So every half hour, we select up to 2,000 SQLs, using this kind of algorithm. So it's quite a few, right? It's a lot more than AWR collects in general. Data curation, well, this is sort of the key thing, right? And the main challenge with data curation is getting accurate deltas. And we're doing proper deltas. What are deltas? You're probably familiar. If you're using AWR at all, you're probably familiar with the concept of, a delta where, whenever you have cumulative stats that are sampled periodically, you're usually interested in the difference between one sample and its predecessor sample, right? What happened since the last sample? And in order to do that, you have to subtract the prior sample from the current sample and get what we call the delta, right? So we're diffing successive samples by SQL ID for the same SQL ID. This is kind of challenging because of the sort of the frequency differences, right? One SQL might execute like thousands of times a minute. Well, you're going to probably see that one every half hour, and all your deltas will be 30 minutes in duration, and you'll have a very nice history of how it accumulated executions over time. But, if a SQL executes once a day or once a week or even once a month, that becomes a little different. Now, in order to do the delta, you got to go back a month or a week or a day, right? So the whole delta thing was actually quite a challenge. In general, what we do is we don't look at deltas that are longer than approximately a day. Okay, so we want to pick up the daily SQL executions. But if a SQL runs once a week, to us, it's effectively going to look like a weekly individual execution, right? So there's a little bit of a challenge there. But what we do is, we basically aggregate these deltas on a daily basis. And what we're trying to do there is really give you a good snapshot, a very good snapshot of your daily SQL workload. And so we call that the SQL Stats daily data object. And that would be the main thing you would use, you would reference when using the SQL Explorer for, doing your own kind of investigations. So next thing we do is we aggregate by force match signature. If you're not familiar with force match signature, we'll talk a little bit more about it when we talk about the cursor sharing thing. But just to sort of discuss this a little bit, we actually aggregate after we collect. Currently, we aggregate after we collect. So if you have a cursor sharing issue, one of the what you're going to see usually is lots and lots and lots of SQLs that have different SQL IDs, but they're effectively the same SQL, right? They differ only in the values of literals that are embedded in the SQL. So what we do now is if we've collected a number of SQLs that have the same force match signature but different SQL IDs, we aggregate those in the repository, in the database as part of doing our insights, right? What we plan to do, and it's definitely on the roadmap, is to pre-aggregate. In other words, to do the aggregation at the collection time, right? And that will provide us not only much more accurate view and insights into cursor sharing issues, but when a database has cursor sharing issues, it will still allow us to collect a lot more SQLs, right? Currently, we might collect thousands of SQLs and then roll them up into a single force match in the repository, whereas what we will be doing in the future is rolling those up at collection time and only returning, the aggregate by force match signature. So that'll be a lot more accurate in the future. Hopefully you don't have cursor sharing issues because, they've been a problem basically since Oracle 7. And there were some sort of back-end fixes that kind of didn't quite work that great in the past. So people don't tend to use them. And, my God, there's still cursor sharing issues out there, even though it's a well-known issue and, it's been much popularized that you shouldn't use, you should use bind variables, not literals. That's really kind of the way to avoid this. But it still happens. It's still out there. And so it's worth doing insights about. So what do we mean by insights, right? What's a SQL insight, right? Well, it's basically what we're trying to do is flag possible issues that you would want to pay attention to SQL. Like I said in the very beginning, the usual case is you respond reactively because some SQL is causing a problem or it's taking too long or users are complaining. And what we want to do is look for those things proactively and help you identify, really, specific kinds of issues, before they become sort of an emergency or, what the manager is barking down your door about. But one thing I really like to emphasize is that these insights are not statements of fact, right? Like when we say there was a plan change, we don't, the optimizer doesn't ring us up and say, hey, I made a plan change. You might want to look into it, right? No, but we look at the SQL stats data we've collected and determine that this data is consistent with there being an important plan change. It may or may not be the case. We definitely have seen multiple plans, but we can't necessarily distinguish plan change from other possibilities, but with a high likelihood there was a plan change. So we don't say that our insights are necessarily statements of fact, right? The data is analyzed and computed over the raw data, right? And in terms of ML techniques, like I said, I don't want to make this about ML, right? Now, why is ML in the title? Well, if it got you into the room, that's why it was in the title, right? Now everybody's excited about AI. Maybe we should change ML to AI, right? But basically, we do basic regression, pattern matching, and we talked a little bit about workload vectorization. That's kind of a bit of a roadmap item. So we make insights at 3 levels. The first level, the primary level, being at the SQL level. So we look for a single plan change, and we identify whether it was an improvement or a degradation, right? And that's kind of important, right? Most of the time, when you think about a plan change, it's usually like the plan change that, the plan change from hell, right? The optimizer made a bad decision and then this SQL went south and then everybody got hung up and it was a big problem, right? Nobody ever tells you about the plan changes that made things better or how much better they made things, right? But that's the main job of the optimizer, right? So, the optimizer's job is to change plans for the better, right? But everybody knows about the bad plan change. Nobody hears about the good plan change, right? So one thing we want to do is quantify good plan changes. Let's tell people how good the optimizer is doing, not just raise the red flag when it's having it, when there's an issue. If the SQL has multiple plans, we'll flag that. Performance trend is where we basically do a little bit of linear regression on the history of deltas, and we look for either an improving or a degrading trend in the average latency. Performance variability, if there's a high level of variability in the average latency for a SQL across our deltas, we flag that, right? There may be something to investigate there. Cursor sharing issues, we talked about that already, so we flag those. And then invalidations, how many times is a SQL chronically being invalidated for some reason? That could signal some kind of application design issue. And then basically these things get rolled up. So the SQL level is really where most of the insights start. And then they roll up to the database level and to the fleet level, right? So at the database level, we say, well, how many SQLs had plan changes in the database, right? And how many SQLs had performance trends, either positive or negative? How many SQLs had cursor sharing issues? And then the one sort of database level insight that we do is we look for invalidation storm, which what I mean by that? Well, basically, invalidation storm just means that a high percentage of the SQLs that were collected in a day had invalidations. I think we say like 80%. If you had 1,000, unique SQL IDs collected during the day, and 800 of those had been invalidated during the day, we would say, hey, cursor, invalidation storm. And it may or may not be the case, but a high number of invalidations potentially means a lot of CPU time wasted re-optimizing SQL that may not have needed it. And then similarly at the fleet level, we roll up how many databases had degrading SQL, how many databases had cursor sharing issues, how many databases had notable plan changes, how many databases had invalidation storms, right? And when you get to the plan, when you get to database and fleet level, we also apply, some thresholds too, right? So, plan changes happen all the time, right? So if we said how many databases had plan changes, it would be all your databases every day, right? Because there's always a plan change somewhere, right? So, we try and we apply some, sort of heuristic thresholds that say, well, there's too many degrading, there's too many plan changes here. Let's look into that, right? So performance degradation. What is degradation? Well, basically, it just means the increase in the latency per execution for some reason, right? Now, degradation could be sudden, right? It could happen that, the SQL is running great, and then all of a sudden it's running terrible and it's taking way longer, right? Well, what could cause that? Well, somebody drops an index that the SQL needed, right? Well, all of a sudden, that's going to be a plan change, but it's also potentially sudden degradation, right? Because the index is there for performance. If it goes away, then performance likely suffers right away, right? Gradual degradation. This would be more or less consistent with, you've got the same plan, and the optimizer doesn't think a better plan is out there, but average latency is getting worse and worse. That's likely due to data volume, right? So cardinality of the tables involved is increasing, and so it's just taking longer to answer the queries. And then execution over execution degradation. That's really kind of a SQL monitoring use case, and hopefully you're familiar with SQL monitoring technology. But if you're actually looking at this execution and then that execution and why are they different, that's where you're really drilling down into a specific execution. That's kind of outside the scope of SQL Insights. But what we focus on is gradual degradation. Now, that said, we're actually looking into the sudden degradation use case also, but that's currently not really what we address in our insights. So how do we compute this insight? You know, how do we look at our data and say, well, it looks like performance degradation? Well, we basically look at the average latency in our deltas by SQL ID over the last 7 days. And we do a linear regression. And what we say is, you know, if the regression explains at least half of the variability, right? So if the so-called R squared is greater than 0.5, like you can see right here, right? Then we say, well, that's a trend. It's not just random ups and downs, you know, if it's sort of, if, like I said, if the linear regression explains at least half of the variability, then we say that's a trend. And the trend could be either positive or negative. Now, what is a positive trend? A positive trend is a negative slope, right? Because a negative slope means the average latency is going down, which is positive, right? So there's a little bit of a Boolean thing you got to work there, right? So in this case, we're showing a negative trend, right? Because average latency is increasing over time, and that's not good, right? That's negative. So positive slope is a negative is degradation, and a negative slope is actually improvement. In terms of user experience, we have basically, you know, kind of three things. One is, there's actually more than this, but three things. Dashboards, which would be the main interface if you're actually, you know, using the service and investigating SQL. And the dashboards are the dedicated ones that we'll see actual screenshots in a minute. And then you can also make your own, right, using our dashboard technology and the explorers. And then we have this notion of news reports. And the news reports are pretty cool, right? So what are these? Well, basically, we right now on a weekly basis, but we're very actively working on the daily, the so-called good morning report, the one, you know, you might want to get in your inbox every day and just check things out. So the news reports just summarize insights over a period of time and present them you can see examples here on the right. You can get an email that has basically an embedded little page like this that summarizes the insights over the last 24 hours or 7 days. Like I said, currently we have the weekly news reports, but we're working on the daily news report too. And these are really kind of upselling to, you know, different personas. You know, not every manager wants to interface with a UI, right? But, you know, getting a weekly summary of important SQL or capacity planning, you know, incidents or insights is quite useful. And the reports also have embedded hyperlinks. And so, you know, if it says database 123 is having a lot of SQL cursor sharing issues, you can click on that and it'll take you right into, you know, the database dashboard for database 123. And then finally, I mentioned these already, the explorers and the data objects are used for ad hoc investigations or constructing your own dashboards and widgets and dashboards. So insights aggregate up, and if you use our dashboards, you'll see these little simple tiles to capture insights, right? So here we're looking at SQL level insights, and we see 6 insight tiles: performance trend, single plan change, cursor sharing, performance variability. So this is intended to be a very quick way to assess whether whether a particular insight is true or not, and you know whether, and in some cases, you know, quantify things. So, for instance, here we say multiple plans. Well, that's true, but how many plans? Well, we've seen at least 3 plans for this SQL, right? You know, the SQL had invalidations. Well, how many? 296. Well, okay, maybe that's a lot, maybe it's a little. there's a color coding in place also here, just so you can quickly assess whether it's something that's more important or not. So if the insight is not detected, then the little dot is kind of gray, right? And it's sort of, you don't pay attention to it. If it's an insight that might actually deserve some attention, then the little dot is orange, right? So a single plan change that represents performance degradation, hey, you probably want to go look at that, right? And then if it's an insight that's true, but it's not necessarily an issue, then the dot is blue, right? So having multiple plans is not necessarily an issue. In fact, it could be very good, right? You could be having multiple plans, each of which is performing well when it's supposed to be invoked, right? Bind peaking can sort of change you from one to the next. But then these roll up, like I said earlier, these roll up. So at the database level, how many degrading SQL in the database? 54. How many improving SQL? 39. How many degraded plan changes? 4. How many improved plan changes? 4. How many cursor sharing issues? And then similar thing at the fleet level. So at the SQL level, we're telling you, whether the insight was true. At the database level, we're generally telling you, how many SQLs had the insight, right? And at the fleet level, we're saying, well, how many databases, were suffering or having this insight. So insights kind of aggregate up. They start at SQL and they roll up to database. But the dashboards drill down. So here we see the fleet dashboard, and you can use that to drill into databases that have interesting insights. And then from there, you can drill down into SQLs that have insights. And I don't have it in this slide, but the mechanism for the drill down is, if you click on one of the insight tiles, you'll get a list of the top, the insight tile might say, uh, 3 databases had plan changes, right? So when you click on the tile, you'll get a list of the 3 databases and some relevant information about the plan changes that will let you say, well, the plan changes in database A look like they were a lot more important to pay attention to than B. And then you can click on that, and then you'll be in the database dashboard for database A, right? And in database A, you can say, well, I got here because I was worried about plan changes, and I see there's, X number of degrading plan changes. If you click on that insight tile, you'll get a list of all the SQLs that had degrading plan changes with some information about, how to kind of make a determination which one is more important to look at. And then you'll click on the one and then you'll drill down to the SQL. So there's a sort of a standard mechanism to step down through these things using insights as the connector. So let's just go into a couple of our insights very quickly, and then we'll be done. How are we doing on time, actually? Doing pretty good. So quickly, here's the fleet dashboard. I just wanted to splash it up so you could get a look at it. You can see the insight tiles on the left, the basic inventory at the upper left. The main visualization is basically every bar is one of your databases, and it's showing you average active sessions over the time period, last 7 days, broken down by command type. So you can see in the store ET database, we have a significant amount of what do we have here? Call method and updates, I guess. I don't know. I'm half colorblind today. But all the other databases are query only. A top database list at the bottom here with some key information, sort of summarizing the insights, right? So list of databases. They're sorted by average active sessions, so busiest database first, but then how many plan changes did it have, how many degraded SQLs, how many cursor sharing. So let's talk about plan changes, right? So, execution plans are basically detailed instructions for processing SQL queries, and they can be very complex, right? And plan changes are normal, and plan changes are very much expected, right? Because data comes in, data gets deleted, things change in the database, and so the optimal way to fetch a given, to answer a given SQL may actually change over time. And that's the job of the optimizer, is to make those changes when they're needed. Um, so, are plan changes degrading performance? Well, I think this is a case where, the few overwhelms the many, right? The few negative plan changes are what most people focus on. And so I tend to think of the optimizer as the bad guy who screwed them over because he made the wrong plan change, right? But that's really not the case in normal circumstances. And so I think that, the issue with plan changes, I think plan changes get a bad name that I don't think they deserve. And that's one of the things that I really hope that will help to address with with this feature is that, plan changes in general are positive, right? I mean, that's the whole idea. And quantifying that and illustrating that I think is kind of important. So the common use case or the common case is, we talked about multiple plans, and the optimizer has many sophisticated ways to handle sort of multiple plans for the same SQL. But the common case is that the optimizer has a single idea about a SQL at a time. In other words, it has a single plan for a given SQL at any given time. But that might change. And so it comes up with a new plan and then has that idea for that SQL over time, right? And so, the pattern we look for to call a plan change is, did we see plan, for a given SQL ID, do we see plan A, plan A, plan A, plan A, and then we see plan B, plan B, plan B, plan B? Well, that's the pattern that we would see for the common case. Single plan at a time, new idea, new plan, right? And so that's what we look for. We look for a pattern, a pattern of, a sequence of one plan followed by a sequence of another plan. And that, now false positives are very possible, right? It's possible that we could see plan A, plan A, plan A, but in between us seeing plan A, plan A, plan A, plan B might have been active. This gets at sort of, our collection mechanism. When we collect every 30 minutes, we say what plan was active, what was the last active plan, because that's recorded in SQL stats, right? So we only really know the plan that was last active when we collected the data, right? And we could have had many plans over the 30 minutes, but when we collect it, we see plan A. And then maybe it has plan B, but then we collect again, we see plan A, right? So we might get fooled by that. But in general, I think that, that's going to be, kind of rare. So false positive and false negatives are possible. We could miss out on a plan change, right? Like, we could see plan A, and then during the 30 minutes, it could decide plan B for 25 minutes and then go back to plan A. Well, we're not going to see the plan B at all, right? We saw plan A in 30 minutes ago, and we saw plan A again. So that would be a false negative, right? But one thing we try to do with all our insights is help you understand how much you should care about it, right? So if I see a plan change, how much do I care, right? I know the optimizer is supposed to, change plans, right? Well, what we try to do is estimate the daily change in DB time, right? So we take the average latency for plan A, we subtract the average latency for plan A from the average latency for plan B. And we say, okay, well, the change in average latency was, X, 10 microsecond or 10, let's say 10 milliseconds, right? Well, how much do I care? Well, how many times does this SQL execute? So if it's 10 milliseconds and it executes 1,000 times a day, well, that's 10 seconds. And if it's 10 milliseconds and it executes 1,000,000 times a day, well, that's however many seconds it is, 100,000 or something. So we give you some idea of how much to care, basically, usually expressed in terms of DB time, which is usually what you care about if you're, worried about performance. Here's the SQL level dashboard, and in the very center of the screen, you can see a chart which shows the average latency over the last 7 days, right? And so by plan, okay? So we can see that in this case, it's at the very left end of the chart. I'm looking at the middle chart here, right? The dots. There was the blue plan, and then it switched to the yellow plan. Then it went back to the blue plan. But now we got the pink plan. And then we're back to the blue plan, right? So you can see this is what we would signal, let's say 1, 2, 4 plan changes, in this view, right? From blue to yellow, from yellow to blue, from blue to pink, from pink to blue. Above that, we show you DB time broken down by weight class for the SQL. So you can, and also we also have a line chart of execution. So you can see how the DB time varies, and also related directly to the daily execution count. And then on the bottom, we relate to IO, right? So it's really, we break down the bar charts are reads, writes, our megabytes of IO per day. And then the line chart is the actual IOPS. So similarly to the above chart, where we compare executions in DB time, here we're just comparing IO to IOPS. So that's really the main this is the SQL level dashboard. Cursor sharing. Are we doing okay? We're almost out of time. So, cursors are the mechanism that the database uses for executing SQL. And, Oracle shares cursors for essentially the same SQL. Why does it do that? Well, because the Oracle Optimizer is actually very sophisticated, and along with that comes sort of a CPU-hungry animal, right? So the Oracle Optimizer can use a lot of CPU optimizing complex SQLs, and that step can be avoided. If you and I and Murtaza are all executing the same SQL, and the optimizer doesn't, and it's a complicated execution plan to develop, why should it do it 3 times, right? So there's a lot of machinery in the shared pool basically designed to share execution plans across executions by different users, right? And that's what the shared pool is mostly about. Now, when you actually write SQL but embed literals, and by literals I mean, actual numbers, like if I select star from the emp table where emp ID equal, and I say 1, 2, 3, and then the next time I run the query, I say where emp ID equal 4, 5, 6, and then when the next time I run the query, I say where emp ID equals 7, 8, 9. All those 3 queries will actually get unique SQL IDs because the SQL ID is based on the literal text of the SQL, and those numbers change the text. And so then they get different SQL IDs. And they become non-shareable cursors, and that's kind of the issue, right? It's obvious that the same execution plan for all 3 of those queries should probably be the same, right? It's probably an index lookup, a primary key lookup on employee ID, right? It's a very simple plan. Why should the optimizer even think about it 3 times, right? So that's a case where the literal SQL prevents the optimizer from recognizing that it's identical to the other SQLs like it, and so the cursor's not shared. The optimizer executes again, uses CPU unnecessarily, just to come up with the same plan. So how do we address the issue? Well, the main way to address the issue is to realize that you've got an application problem and it really should be rewritten. Now, way back in Oracle 7, there was a sort of a back-end fix invented called cursor sharing equal force, an initialization parameter that could basically tell the database, hey, anytime you see one of these literals embedded in a SQL ID, just turn it into a bind variable and then compute a SQL ID, and then they'll come up with the same SQL ID. There's a lot of the cursor sharing equal force kind of worked pretty well in some cases, in many cases, but then it didn't always work so well, and so it's not that common to see it being used. Anyway, so what do we do in terms of our insights, right? Well, first of all, we aggregate the stats for non-shared cursors that have the same force match signature. Force match signature it's kind of like the SQL ID without the literals. So and then we compute our how much do I care, right? Well, how much do I care about cursor sharing? Well, how much I care is really kind of, how much CPU time am I wasting by doing all this unnecessary optimization, right? And so we try to we try to estimate the excess hard parsing time by basically, it's a little bit of a in the weeds thing, but in SQL stats, there's an average hard parse time column, right? And so it tells you basically how long it took to hard parse the SQL statement. And in the case of literal SQL, usually they only get hard parsed once because every one of these things hard parses itself and executes once, right? And so, the hard parse time is really approximately, the total hard parse time across all of the executions is approximately equal to the wasted CPU time. And so that's what we basically, say. It's kind of a lower bound because, like I said, we're not rolling up the stats at collection time. We're rolling them up after we've collected. So it's a lower bound estimate. In other words, if we actually signal that there's a cursor sharing issue and that there's this much excess hard parse time, it's probably really the tip of the iceberg. There's a lot more out there, right? We're not making a statement about how much the cursor sharing issue is affecting you altogether, just how much excess CPU we've observed in the SQLs we've collected, right? And this is basically the database. So database dashboard, I just wanted to flash up all the dashboards to give people a little bit of a sense. I won't go through all of this in much detail, but again, we break down SQL activity by command, by module, by whether it's SQL or PL SQL, SQL activity over time, broken down by statement type, insights on the left, top SQL list at the bottom, some charts here. The SQL and invalidated SQL is basically so you can sort of verify the invalidation storm insight, right? So if your invalidated SQL count is 80% of your SQL count for any given day.
And thank you so much, Murtaza and JB, for all this great content. If there are no other questions, I can go ahead and conclude this call. Have a great day, everyone.